Let's start by asking, what is a system? The world around us is very complicated. Lots happens, sometimes fast and sometimes slower. As a geographer, we strive to reach a position of being able to interpret this complexity, to understand what is happening. We want to, for example, know why we are stuck in a traffic jam, why there are solar panels in a field, why bluebells might flower in May, why one beach is sandy, another one stony, and so on. To work this out, we need experience, and we need to have some knowledge of systems, of the relationships between factors in front of us. So we break the world down into a series of inputs, stuff that happens or is created and so on, and then outputs. We can apply this idea to a range of scales to help us understand what happens. A coastal landscape can be an open system whereby stuff, matter, and energy comes in and out. Sediment, wave energy, and so on. Some systems retain their matter and only energy is lost, and only energy is added. This would be an example of a closed system. The Earth's water cycle is a closed system, i.e. no water is added to the global water system and none is lost. So, we learn all about these systems. We can then, in our mind, layer them on top of one another, and we can interpret the world around us. We do this naturally anyway, but here we are establishing that it is a systems approach to thinking that we're considering here today. So let's now consider negative feedback, and I've put a smiley face there because this is, generally speaking, a good thing. A system can sometimes be knocked out of the delicate and balanced state in which it exists. Negative feedback is about the system being disrupted, being upset, and then the system, perhaps Mother Nature, kicking in and correcting that change. This is where the idea of a system being in dynamic equilibrium comes in. The change happens, the system changes, and then it is corrected. The system is dynamic, it can change, but perhaps it is self-righting. Let's have a look at this example. So here we have a change happening, which is, in this case, burning of fossil fuels. That causes there to be more carbon dioxide in the atmosphere, which increases the temperature, so more vegetation grows. And you'll appreciate my brilliant diagram there of vegetation. This means that there is more carbon dioxide absorbed, and that is then stored in the biomass in the trees, and then consequently in any animals that might eat those trees. This means that because it's been absorbed by the biomass, there is less carbon dioxide in the atmosphere, and what's happened therefore is the system has corrected the change. Equilibrium has been restored. It's worth putting a little footnote on the bottom of that to say, hang on, actually, this is quite a theoretical idea, and current evidence suggests that we've got human-induced anthropogenic climate change, so actually maybe that's not really working as it's described in that little flow diagram there. To work in a second example, we could start to think about beach shape over the seasons. So in the summer, we have more constructive waves, possibly in the UK, which push material up the beach with their strong swash, which steepens the profile of the beach and widens that beach. Then, when winter comes, we get more destructive waves with a strong backwash. These are going to pull material back down the beach and possibly even pull material offshore. This will steepen the beach and it will also narrow the beach. This is dynamic equilibrium. The beach actually will then seasonally change because the next summer will come, more constructive waves will come along and they will push the material back up the beach and back onshore. So seasonal changes and the beach being in dynamic equilibrium. Okay, let's talk next about positive feedbacks, and there's a sad face there because positive feedbacks usually mean bad things happen to systems. Here, a change occurs in the system, and rather than the system being able to correct itself, the change gets more and more extreme. This is most easily illustrated via the current anthropogenic, human-induced climate change. We burn fossil fuels, we chop down trees and so on, and this causes more carbon dioxide and other greenhouse gases in the atmosphere, which is obviously a bad thing. Positive feedback then kicks in and amplifies the effects of these warming, and we get runaway climate change. Examples of that might be, well, the Earth's albedo, the reflectivity of the Earth, where we get more dark surfaces when ice melts. The surfaces absorb more heat, causing more ice to melt and so on, and the effect of that little bit of heating gets bigger and bigger and bigger. Similar effects can be seen from increased water vapor in the atmosphere, from ocean acidification and temperature rise, from plant stresses and wildfires, from permafrost melting and the consequent decomposition of organic matter stored there, and so on. All of those things might go from us having a 1 degree, 2 degree rise in temperature of the Earth because of burning fossil fuels and things, then a consequent 5 or 6 degree change in temperature, which would be catastrophic. If you want more information on some of those positive feedbacks, can I suggest that a really good video for that is called Wake Up, Freak Out, which was produced way back in, I think, 2008, but is a really, really good resource linking the concept of tipping point and positive feedbacks and the current climate emergency. I'll leave a link to that in the description. Before I finish, one more little example, which is slightly more wacky maybe, and certainly a little bit less linked to current climate change ideas. But here we get a little bit of cooling of the Earth could occur. We had a cooling phase during the 60s and 70s, which some people thought, oh, here we go, this is us going into a new ice age, and they were concerned by this. People even thought that was maybe human-induced. But anyway, we could have a little bit of cooling of the Earth, which means we get slightly more ice. Then we can link back to that albedo idea again, where we get a more white Earth, meaning more sun's light is reflected out off into space, which means that less heat is received by the Earth in terms of it being absorbed by the Earth, leads to further cooling, and so on. And we go round and round and round, and eventually the Earth becomes one big snowball and life on Earth is extinguished. That's not a huge concern today in terms of current thinking, but it's an interesting one to consider as a positive feedback.